multi-Pi Awards winner, and last year he won the award for the technical. The technical award at Pi was for his robot face plant. He also runs the Robot Club at Cambridge Namespace, and he's a leading light in the Pi Awards community. So please join me in giving a warm welcome to Brian Corteil.
Thanks, Rob. Hi. I don't know if you've seen previously, but I'm going to talk how to build a Pi Wars robot. For last year's, or sorry, this year's thing, I came up with this silly idea that I was going to make a balancing robot. And I went back and actually created all my noob mistakes that I made the first time round. This is just a selection of some of my past robots and what I've done. So, just to show that the most important one is the one at the top. You see that one where I came in the bottom third of the competition. If I can improve, as I have done each year, everybody can. As saying, I'm not the world's greatest programmer. My thing's hardware. So, just as a quick thing to do, just to make everybody think, there's only a few days to the thing, to Pi Wars. So this is about faceplant. Faceplant is a BalanceBot. It has two motors and on each of the wheels, and they are can be continually being adjusted in a PID loop, and it's pain. It took me 6 or 7 months to be able to get it so faceplant could actually stand up. Some of the technology that it's using there is an IMU, which is a really clever sensor that has 3 types of things. So it has a magometer, which is a compass. It has an accelerometer, so that records shocks. And it also has a gyroscope that should hopefully give a position of where it is or where it's pointing. And these are all combined and fed into a loop, which is hopefully will keep the robot upright. It was a bit of a process. Press Control C. If you're wondering where faceplant got its name from, I think you might be able to guess. And as saying, it's a thing. So after about 8 months, someone was able to do this. So able to share and fall in its place. So yeah, it has been a big thing, and I ended up making all the, as I said before, made the mistakes that I made first time round. So well, I only actually got it started moving in February. That's not a great amount of time. Oh, that was actually an arse plump. Thank you, my glamorous assistant. So you really need to be able to start programming it for your system as soon as you can. Getting a stable base up and running so you can practice driving it. That having a way that's on board the robot to be able to actually choose between the different challenges and your settings is a real big advantage. Don't do like I'd done and make adjustments on the night before. Faceplant really lived up to his name until I realised that I didn't tighten up one of the wheels up properly. Driving practice, well, it was in February, as I said before, my other robots, I've been driving them from a couple of months in. Code testing, well, I wrote it and ran it. And one of my earlier mistakes, which I should have known better, was choosing the wrong driver for the motors that I'd chosen. But happy to say that.
Nasıl? Güzel. Gel yavrum, gel.
Okay. So, but
It's not quite on. I like you can hear again. It's not quite on.
So what I'm trying to say with showing the pictures of face planting is that at times it will fail. Failure is actually the best and most expensive way to learn. But you learn from your mistakes, you build up from your errors. So one of my favourite things is that I get my left and rights mixed up, so the robot goes right and it should have gone left. So that's where testing your code, making sure it runs, having a nice strong memory structure will help with your things. So I want to run over some of the things about actually choosing a robot you're designed for a Pi Wars robot. So as you can see, there's quite a few types. So saying this one, rubbish. Thing. So the freewheel robot, I will go into detail of those. So you've got the different types of robots. So let's actually have a look at some of the types individually. So freewheels. This is the most common sort of like beginner's type chassis. This is built from a Raspberry Pi case and a cam jam kit, and that's all it is. And sticky tape, lots of sticky tape. Thing. So it's a fairly simple build. It's sort of like 2 motors, one out of the back that doesn't do anything apart from get caught up on everything like that, but it's a good thing. Pi Wars, you want more than 2 wheels, to be honest, more than 3 wheels. They don't have to be all power driven. So you got the next one, 4-wheeler things. This is the standard Pi Wars robot. It's very much like, I know you can't see it on the thing, but the little rover that I drove up on the stage. 4 motors. Big meaty motors in the corners is normally the best thing, and reasonably sized wheels. The only disadvantage is that if you're making your robot larger, is that you can find it more difficult in the course. Yes. Next is that we've got a 6-wheel drive. This is my winning robot from 2016? No, 15. This is when we were able to build up to A3 size robots. You have a lot more space for stuff, anything like that. It's actually quite a good choice. If you can get 6 wheels in the smaller format, it's a really good choice. It's got all the advantages of Caterpillar tracks without the grief. And the thing, so I stole a picture of a Glittiator because it was a nice track one, and I went Pi Wars robots. Tracks. The big problem with tracks is that if you're doing a custom build, it's actually getting alignment of them. They sort of like fall off, they don't grip, and can be sort of like they're tricky. The good thing is it'll turn on the spot and it'll climb over almost anything until up to the extent of tipping itself over. Then, I went to the trouble thing. We've got an Omnidirectional. Yay! This is one of my favourite robots from last year. Oh, sorry, this year. It's they're just awesome. So they have a distinct advantage in something like Pi, known as they can go around in any direction, step sideways, drive strafe. They're really hard to fight against. The one thing that most probably lets them down is that they find something like the obstacle course quite difficult. Not a lot of grip when you're going on the vertical slopes, or not going off the horizontal, but really manoeuvrable. Oh, and they can be a pig to program as well. That's why I haven't made one. Walking, I haven't got a photograph of the thing, so I went for my favourite one. It's a robot, isn't it? I don't know a lot about robots, walking robots, apart from I imagine they're going to be quite slow, and if they're fast, they're not. For Pi Wars, they'd be great fun, but I wouldn't expect to think. If you want to win challenges, it's 4 big meaty motors on the corners. Is the normal. So, so it looks cool. I didn't put that. It looks cool. The front is actually, once you actually get in so it doesn't fall on its face all the time and things, it actually does go really well on the flat surfaces type challenges, and it would turn on a sixpence. But you do have things like the platform's moving, so your sensors are moving, and everything wobbles, and it falls over on its face. So this is the thing, how big do I build my robot? So my first robot is not the pirate ship. Thing. And this, it was in the first Pi Wars, and this event was Sumo. Who do you think won? Thing. So, large robot chassis going up to sort of like close to the A4-ish measurements is that you can get lots of stuff in there. You can get big motors, big batteries. In lots of ways, it's an easier build. The disadvantages are that you may find it quite tight to turn on some of the courses, and there can be a little bit more. You ain't got the skill, have you? You think? Press the button then. Stay. Yeah, so big robots, they can be tricky to get to turn in spaces and that and things like this, but as I'm saying, you can get lots of stuff on them. And small robots, those smaller robots, I categorise a small robot as being sub A5 size. They're more manoeuvrable. You can turn them in, you can do a 3-point turn in some parts of the courses where you couldn't do that with one of the bigger robots. You can't use big meaty robot motors unless you're really clever on the design. And they've got small wheels, so theoretically they can't go as fast as a bigger robot with bigger wheels. And there's less space for stuff unless you're really clever, or you're going to start going into the realms of actually building custom PCBs and stuff like that to be able to squeeze it all in. So, yeah. So, so equipment selection, motors. So the most two important thing is that you need to balance your motors and your motor driver. When you're looking at the motors, there's something called stall current. That's when the motor's locked up, powered on, and it will drain its highest amount of things. Basically, you're short-circuiting. You need to make sure that your motor driver can hold that. And when the manufacturer says it can hold 20 amps in 50 microseconds, that's not a lot of time. Test it, make sure you get the balance right. If you're looking for some good ones, I like the Fortronix Pycon Zero. The one thing I dislike about it is that you have to run a separate power source for the Raspberry Pi. Some people say to me, will argue against me and say, well, that's actually not a bad thing anyway. He does make a full-size hat version where that does actually have a drop-down DC to DC power conversion on it. And I like the Red Robotics Red board. I was straight up. Neil gave me a pre-demo board to have a play with and things like this, and it's a really nice board. And I think the only thing he's forgotten is the kitchen sink, to be honest. And I do wish that I made it myself. So next thing is sensors. So sensors are everything. So on most of the challenges this year, you're going to be looking at distance sensors, maybe color sensors. There's pros and cons for each of the different types of sensors, which we've got sort of like sonic, time of flight and IRs. So time of flight and IRs are really the same sort of sensor, but the time of flights are more modern and give better results. And then you've got the camera for doing OpenCV stuff. And from what I really see in this year's challenges is actually, unless you're in the advanced category, there's not so much reliance on computer vision stuff. And then you've got line following sensors that you may find. If you want to ask any questions about this stuff, come and grab me. I will willingly talk the hind leg they got for donkey about it. And I think I would just want to say something about this. This is one of the cheap available drivers that you find on eBay. You see the big black fin and the thing. That's on there for a reason. That's to get rid of heat. When you're getting rid of the heat, that's wasted power. And so it's possible that this, when you're using this will drop somewhere between 1 and 2.5 volts of your outgoing voltage. That's the power to your motors. That's not good. And so if you pay, say, putting in about 9 volts, 12 volts, so you're losing somewhere in the region of 20–25% of your output. So if you can, avoid those. That being said, they're great beginners. Thing. Choice of your pie. So we've got so many pies now. You think, why can't we have the red, the blues and the red ones? They're much more pretty than the green, aren't they? So it's a choice of what pie do you use for Pie Wars. It really comes down to how much computing task you go into. The more computer power you want, the more power you're going to need to be able to supply it. My personal favourite is that I like the Zero WWH. It's the powerful as the last of the single core processor pies. You can make a very good simple robot with those. Not much cop for the OpenCV, the computer vision stuff, because it hasn't got the additional resources like memory. It's not as fast and so forth. Until the Pi 4 was brought out, my new favourite is the 3A Plus. It's powerful, has a reasonable amount of memory, it's fast. The only disadvantage over the Zero is that it will use more power. But really for Pi Wars, as long as you've got a spare set of batteries and you're swapping out and charging throughout the day, that won't really matter. And you can see, so that's as I've summed it up. And controls. So I want one of these. In fact, I just need to have the ice cream thing to go on there so I can put it on, but yeah, that would be awesome. And it's got a big red button. So, controls. So you can use a wireless keyboard, or you can go over a network. I wouldn't recommend going over a network to control your robot, because it's possible that on the day it's going to be thing. The local networks are going to be rammed. Also, if you're using, say, a keyboard to control it, it can be very virtual on-off, and unless you've got other ways of selecting the speed of it, the control of it is not as precise as using a game controller or the blue spot app. Game controller, there's a lot of cheap ones. The Pi Hut controller is okay. And then you have things like the ones that I also recommend, which I can't remember. But they're no, it's gone. Yes, the Rock Candy style controllers. They're great for testing when you're at home. On the actual day at Pi Wars, they're very promiscuous. They'll go off with any other robot. They say, "Oh, I like that robot," and it will be friends with that robot forever and a day. So bear in mind that if you do use one of those cheaper type of robots, is to continually make sure that you've got connection. When you're not using it, shut down your robot completely. And when you're in the pits, make sure your robot's on a stand, so if it does get taken over, it's not going to shoot off across the room and go into 3,000 pieces. There is an alternative to all that. There's an Android app called Blue Spot, and it gives you a blue spot on your phone. And with that, you can actually have really reasonable control over Bluetooth of your robot. If anything, it's a really good option to have as a backup. So, and there's 2 libraries. So you've got the Pygame library, or you've got an approximate engineering input library. They're good places to start with, Python libraries. The approximate engineering's got some great examples to get you started. So, what did I do? Computer vision. So, there's 2 choices. You can use the official PyCam or one of the third parties. This involves some quite heavy coding and understanding OpenVision, or you can check the Pixie and the Pixie 2, and there's some other types as well. They do all the colour sensing stuff, and then they just give you, as I see an object of this colour at these locations, at this location, and it does it continuously, and it can do it so much faster than the PyCam. So, as saying, it's really a thing. I'm going to talk a little bit at the end about a thing of that. I've started a project up called CV0. It's hopefully to be able to get the advantages of the Pixie cameras. Actually has a Python library for the robots, but the same this year it's not so important. Sorry, next year it's important. Right, what else did I put on here? Oh, this is one of my early tests when I was doing that. So, once again, it's really essential to test code. Always test your code and keep on going there and keep on bashing away. So, okay. So this is the big secret. This is how you win PyWars. Thing. Enter everything. There is always points, unless you really cock up and get minus points, but I don't think they would actually go towards the your end total. So it's better to have an average across all the challenges than being really good at one and doing rubbish at everything else. Being Mr. Average makes you a winner. I can't stress that out. And also driving your robot a lot. So, build quality. This is an easy way of getting points. And saying, you know, saying I built a stupid robot and I got points. So, these are just some tips on it. So, when you're building your robot, don't you, breadboard is fine for when you're doing your prototyping. When it comes to the last few months, you want to transfer it over onto a more permanent basis. It saves loose connections. It makes the running and the reliability of your robot so much more. Yeah, I can't stress the thing. If you want to know how to do that, come and talk to me and I'll tell you how to do it. Wiring, bird nests. Keep the wiring nice and tidy. I'm saying they're not for robot, but, well, maybe for that robot, but they're not for a robot. When they're in a bird's nest, it's where it looks like there's just been an explosion of cables in a cable factory, all tucked into your robot thing. Now, make sure your batteries are secure. There's nothing worse than you going over a bump or having a small whack, which you've driven into the wall, and your battery disconnects. So make sure it's secure thing, but that said, also having a way that you can actually disconnect it really quickly in case of there's magic smoke. Once again, I can't stress this how much. Keep your cabling tidy. It makes life so much easier for you, and it'll get you points in engineering and in the build quality. And also the other thing is have a colour scheme. You don't want to be there on the day when you're under stress thinking, now, is it the purple that's the positive or was it negative on this sensor? And on that sensor, was it white the positive and the black negative? Keep your colours the same. Use the same colours for data. Use it the same. I always use something like a high voltage is red, low voltage is yellow, but have a colour scheme. It will save you time and so much headache, and it will also get you more points. So I'm not sure about this one. So have a theme and keep to it. If you're building your robot from a kit, and there's no, you know, having a kit as the basis of your robot is a great way to start. Skin it, make it look original, make it have fun, have small details that are there to enhance the design. It's one of the bits is that you can get the people involved in your team who are not the most technical or anything else to be part of the project and have ownership of the robot. And it's 3 points. They're saying going up there and standing in a queue looking bored and talking to other people for 15, 20 minutes is worth it because it's points. And the points make the prices. So thing. Yeah, as I say, no breadboards. So I would try to aim for the chassis. You drive in chassis by January. It gives you enough time to revise if you need to, get practicing. To be honest, November's better. If thing. Build test courses, test your code, or come to our robot club, Cambridge Makespace Robot Club. We will try to copy, rip off most of the designs as possible for the people to practice. It's like, practice makes perfect. It's so true. Drive your robot. Drive your robot for 3 or 4 hours every week at least. I know it sounds loads, but it will get to the stage that when you know that you will need to do a left turn, your thumb will go there before you even thinking about it. If you're doing any of the computer vision challenges, you need to have a way to calibrate the colours. I can't stress that is so important. Unless you're really, really clever with your coding and things like that, you will need to calibrate. And also calibrate your line following sensors, check them and make sure they're working. And you need to have a menu system. It can be an LED and a single button. You press the button and it flashes 3 times and that tells you that whatever program's loaded, but have some way to do it on the robot. Every time you're connecting up a laptop and swapping programs over, if you're really unorganised like myself, you've got chances of loading in test codes from 6 months ago where the robot went left instead of right. And the test course don't actually have to look like the maze. So this square donut was actually a test course for the maze. I just needed to know that the robot could turn left or right when it was told to. And yeah, it did work. It did work. Like a tweet, I didn't take any videos of it working, but okay, software. Oh, by the way, don't get 2 bears to check your code. They're rubbish. So software, start early. 175 days, that's, what, 6 or 7 months away? Maybe a little bit more. If you break it into in weekends that I can program things like that, it's not actually a lot of time to start. So even if you're just writing out a rough thing, at the start, start building your menu system. I would say that's the most important thing to do after you built your drive code. Oh yeah, and having a way to power down your robot other than pulling out the fuse is actually quite a good thing. And as I said before, your interface can be a single LED and a button. I wouldn't recommend it, but it's better than nothing. Okay, on the day, spare batteries. Already charged for your robot and your controller. Have spares of key components. This stuff is just so you don't have to worry about it, because if you've got all these spares, you're not going to use them, are you? If you haven't got them, you're going to want them. If it's possible, get early and be rested. I'm silly. I'm still up at 3 o'clock in the morning the day before, panicking, but that's on that. And if you are entering your robot by yourself, have a buddy. You know, somebody to carry around to mop your brow, get your drinks, tell you how wonderful you are. That one's particularly good. But the most important thing, if you get there on the day with a robot that moves, you've done something amazing. The day is there to be fun, for fun. It's stressy fun, but it's fun. We've got a great community, and yeah, I'm saying it's there to have fun. I'm saying this little guy's having fun already, and he's not even entered. Okay, so I want to talk about a couple of things that are sort of the thing. I nicked the Pi Noon idea from Pi Wars and miniaturized it. I take it away round to jams and maker fairs and sort of like STEM events and stuff like that. And the idea is I believe that something hands-on is more of something of grass thing, and then a very boring static display. You know, and unless it's playing video games, who wants to look at pixels moving across the screen? So Pi Noon is a 1 meter square arena inside the walls. The idea is that you try to pop the other things, and the robots are A6 sized. This is a great way to have fun practice your robot building skills and actually get some real proper practice. If you've got a hat space, a school and stuff like this, and you can make your arena 1 metre square, it can fit in the back of a cupboard. It's great. I can't explain. And finally, I've got, that's running through when we was doing Over the Rainbow Challenge a couple of years ago. So I started this project up, CV0. It's hopefully being able to get a Python library that will make computer vision more simple for everybody to use, so we all got a fair chance. If you want to go off and code your own solution, that's not saying, you know, please do that, but I need help. I'm not very good at this part of the thing. I just found out the other day that you don't actually have to tell OpenCV that you've got a camera connected because it's clever enough to work it out for itself. We got the GitHub there is where the start of our code is, and there's a few documents and things like this. And tomorrow we're having arranging a hackathon at Cambridge Makespace, and it'd be great if you could come and help. So that's me done. Have we got time for questions?
Yes, actually we have time for questions.
Okay, has anybody got a question? I may be able to give a sensible answer.
Can I just add that backing up your code off unreliable SD cards is very good.
That is an excellent idea. I should add that on the slide. I'm going to steal that. I'll put by Amy Stead in small letters. Very small letters, but yeah. Hey.
Are you going to publish your slides anywhere?
Yes, I will do. I will put them up to my GitHub account. I will shout about it on the Twitters and ask Rob if he can email the attendees after we're done. Okay, cool. Thank you. Hi.
Over all of the years and all the competitions, what's your favourite and least favourite?
The least favourite was the first year. Because I made so many stupid, silly mistakes that could have been avoided. I had code where I'd written it worked, I tested it. 3 months later, I changed the way that I had the wheels around, and I didn't realise that until the day. And yeah, it was not great. My favourite ones, as the 2 years I've been Ipswich. So yeah, to be honest, I'm saying I enjoyed it. I've enjoyed everyone, and it's really hard to be able to pick favourites and things like this. It's been, yeah, it's a good, friendly event. The community's amazing. I can't say anything more than that. It's great. Any more? Hi, sir.
I did notice that pipe installation features heavily on your robots, but you didn't mention that.
Oh, the pipe installation there is for bumpers.
Yes, it's on all of them.
Yeah. Yeah, my robots crash a lot. I think. Yes, go for the heavier density that you can find. Yes, it does work well. The first robot, Revenge, have we got a picture of it? So this is a lesson for everybody. So you can see we've got the pipe lag on that. The reason was that I first built that with 1,000 RPM motors. It flew. The only problem is that the motors are cheap Chinese ones and they crashed the driver. And it kept on flying and flying. And it was just a little bit faster than I could run. And as you can see, the big blue thing at this end, that's the battery. That goes forever. So, yeah. Yeah, Yeah, or just a kill switch on the robots, and when you pick it up, the wheels are going around at 1,000 RPM, and you can't put your fingers where do you need to disconnect it. Yeah, it's crazy. Any more?
Are you building an interesting chassis this year?
No, I'm building a boring chassis this year. So, this chassis this year, well, it may get interesting in the motors. This is Sherpy. It's the prototype for this year's robot. I started early. It's got 4 not so meaty motors and big stupid wheels. This can climb 70 mil without things. So anybody's building any parts of the obstacle course, make your walls tall. This is really a prototype to test ideas of design, see how the wheels would actually work and things like this, and it's stupid. It will, so I don't know if, as you can see, it's stupid. Yeah, big wheels, stupid. I should have learned from Faceplant, but I can't resist them. So there was a gentleman after Mark. Oh, batteries. My favourite are unprotected lipos. They can make your life in very, very interesting ways. You need to be careful with them. It's not something I would recommend if that you're new to doing with robots and you haven't come across lipos. They need to be discharged with respect. They need treated with respect. Why am I with? Well, they're like a small hand grenade in your pocket. They're quite scary. But they have the best power density. They've got the best power response. So all the pros outweigh the cons, in my opinion. If not that, is that good quality rechargeable batteries that you double A's, treble A's. They have fairly high resistance, so they can get hot and make fires, but they do it a lot slower than lipos do. You've got more chance of smelling the magic smoke before it's released. Then you've got dry cells. The dry cells are your normal disposable, unfriendly things. They're good if you want sort of like a bit of a power increase, because their normal voltage is 0.3 volts, and when you're on a speed run, every volt counts. That's really the 2 choices for batteries, I would say. So, hey.
And we have time for last question, maybe?
Oh yes, yeah, modular design's fine. The only thing is that you need to make sure that the basic robot doesn't change, so it doesn't morph into a walking robot when it was actually started off as a rover. But I'm sure you get points in artistic merit and technical if you did. So yeah, modular the game is it's being able to swap out a grabber because you're picking up barrels, or putting a bulldozer front because you want to be mean when you're in High Noon. I didn't say that because you're not meant to do that. And so yes, modular's fine as long as you at the heart it's the same robot. So.
I think we can take one last question. One of the kids wants to ask a question.
Oh, cool.
No, you're fine?
No?
So can we just give him a warm
Yeah.